Hello everyone, welcome back to Equilibrium of Forces. Today we will see how to solve problems on equilibrium of forces. Before going into solving equilibrium of forces, let us look into what are the steps to be undergone to solve an equilibrium problems on equilibrium of forces. First thing is to draw free body diagram of all the points in a system of forces such that I'll just read out whatever is there in this slide. Draw free body diagram of a point in the system, an object in the system, complete system of objects in equilibrium, and while writing FBD, we have to consider all the forces acting on the system, including the support reactions. Now, if the problem we are dealing with is of concurrent force, we use these two equations, that is summation of all horizontal forces equal to 0 and summation of all vertical forces equal to 0. On the same lines, if the given system of force is a non-concurrent system, we use one more relation, which is summation of moments about a point to be equal to 0. After equating these three equations or these two equations, next thing is to see if the system of forces we have got is 3 or more. If we have got just 3 forces, our problem solution becomes very easy. We just have to use Lemmy's theorem. If we have more than 3 forces acting at a point, then we have to draw free body diagram for all the components and then start solving with the free body which has got minimum number of unknowns. Also, for an object hanging freely from a cable, the tension in the cable will be equal to weight of the object. Now let us see how to solve a problem. Here we have got the first problem. A 400 Newton sphere is resting in a trough as shown in the figure. Determine the reactions developed at contact surface. Assume all contact surfaces are smooth. We have to look at this point and assume that the friction between the point of contact is 0 or no friction at all. Now, in this system, there are two point of contact, that is one at this edge, that is 45-degree support, and another one at 60-degree support. The free body diagram is here, and before writing the free body diagram we have split the entire sketch to find out all the respective angles. Here this is 60-degree. If this angle is 60-degree, the reaction at this point will be at 90-degree at the point of contact. So this angle will be equal to 30 degrees. Similarly, 45, 90 and 45 to the other side. Expanding this, our free body diagram becomes this way. 400 Newton is the weight of the sphere falling downwards, and we have a reaction R1 towards 60-degree and reaction R2 towards 45-degree. The angle subtended will be equal to, here we have got 60-degree and 45-degree. So the total angle will be equal to 60 plus 45, and this angle will be equal to 180 minus 135, and this angle will be equal to 180 minus 120. Sorry, 180 minus 60 and 180 minus 45. Now, since there are only 3 forces, it is very easy for us to apply Lemmy's theorem, which is force will be proportional to the sine of the opposite angle. Therefore, R1 divided by sine of 180 minus 45, R2 divided by 180 minus 60, and 400 divided by sine of 60 plus 45. First, equate these two equations, find out R1, and equating these two equations, we can easily find out R2. Coming to the next problem, here we have got find the tension in the string and reaction at the contact surface for the cylinder of weight 1000 newtons placed as shown in the figure below. Solve by using Lemmy's theorem. It is very easy to solve this since they have given that we are supposed to solve it by Lemmy's theorem. The given sketch is this. The surface is inclined at 50-degree and a sphere is supported with the help of a string at 20-degree. In order to solve this, let us take the free body diagram. In order to write the free body diagram, let me resolve it this way. We are looking at the expansion of the sketch. Here we have the sphere 20° and 50°. If I write a line parallel at this point, since this is 50° with the alternate angle property, this total angle will be 50°. Hence, this angle becomes 30°. If this angle becomes 30° and if I complete this as a right angled triangle, this angle being 90°, this angle will become equal to 60°. 60°, 30°. And if I take out a perpendicular at this point or the perpendicular reaction at this point, if this angle is 30, this angle will be equal to 40. How will this angle be equal to 40? This reaction is subtended at 90° to the point of contact. If this angle is 90° and this angle is 50°, 90 minus 50, this angle will be equal to 40°. These two angles being alternate angles, this angle will be equal to 40°. And if I extend this line and these two angles being alternate angles, this angle also will become equal to 40°. So we have 90, 40, 30 and 60. Coming back to our problem, the same thing is expanded over here. The weight of the ball will be perpendicular towards the ground surface. So W, and a tension, this angle will be, this string will be posing a tension which is taken as capital T, and a reaction at the point of contact which is taken as R. The angle subtended will be equal to, this is the tension and this tension string is inclined at 30° to the normal or to the horizontal surface. Similarly, the reaction is inclined at 40 degrees and this angle will be equal to 180 minus 30 minus 40. The same thing is taken over here as the free body diagram. Weight, reaction and the tension angle subtended are 110, 130, 120 respectively. With the on applying Lemmy's theorem, we can easily find out capital T and capital R to be 815.2 and 921.6 newtons respectively. Here we have got in this, the problem statement goes this way. Following figure shows a lamp with shade being fixed by two strings. Determine the tension in the strings. This is a very easy problem, direct problem. The free body diagram will be this way. Weight of the lamp, the first string and the second string. First string is TA, second string is TB, inclined at 45 and 60 respectively. If this is 45, the alternate angle will be equal to 45°. If this is 60, and this angle will become equal to 30°. So since we know all the angles, this total angle will be equal to 90 plus 30. This angle will be equal to 90 plus 45 and this angle will be equal to 180 minus 45 minus 30. So applying Lemmy's theorem, we get the solution as TA to be equal to 10.98 newtons and TB to be equal to 13.44 newtons. Here we have got determine the magnitude of force P applied in horizontal direction to hold a block of 1500 Newton on an inclined plane as shown in the figure. The problem statement is very simple. We have a horizontal surface and an inclined surface at 30°. A block is kept on this inclined surface and a force P is applied over here. How do we solve this problem? Weight of the block will be falling downwards, that is 1500 Newton. Force is horizontal, that is given here as P, and the reaction will be perpendicular at the point of contact, which will be inclined at 60° to the horizontal. Direct problem, angles will be, this will be 90, this total angle will be equal to 90 plus 60 and this angle will be equal to 180 minus 60. On solving, we get the reaction will be equal to 173,732 newtons and the push required will be equal to 866 newtons. Now comes the problems on spheres. Two identical rollers, each of weight 200 newtons, are supported by an inclined plane and the vertical walls as shown in the figure. Assume smooth surface of contact and determine reactions at all contact points. We have two spheres, sphere 1 and sphere 2, which is resting on a wall and inclined to a surface at 30 degrees. Now, in order to write the reactions, what are the point of contacts we can observe in this figure is there is a point of contact with the wall and this second sphere inclined at this surface, and one more inclination at this point, and the sphere 1 will be pushing sphere 2 will be pushing sphere 1. So there will be a reaction at this point of contact that is represented as RA over here, RB, RC, and RD. RD, when you are considering sphere 1, it will be pushing sphere 2, hence this direction. And when sphere 2 is assumed or under observation, sphere 2 will be pushing sphere 1, hence the opposite direction. Apart from these, weights of the spheres respectively will be falling downwards. So we are supposed to write reactions for both sphere 1 and sphere 2. Now let us look at FBD for roller 1. For roller 1 or the sphere 1, weight will be falling downwards and reaction RD and reaction RC. Reaction RD is inclined at 30 degrees, reaction RC is inclined at 60 degrees. We can directly apply Lemmy's theorem and find out RC and RD. After finding out reactions RC and RD, we are supposed to consider second sphere. In the second sphere, we have four forces, RD, RB, RA and 200 newtons. We already know 200 newtons. We have already found out the value of RD. We are supposed to find out RA and RB. Since this is a concurrent force, we can directly apply sigma Fx is equal to 0 and sigma Fy is equal to 0. On applying sigma Fx is equal to 0 and Fy is equal to 0, we get two equations, and solving these two equations, we get the value of RA as 230.94 newtons and RB as 288.67 newtons. This is a direct problem which I'll leave it to you guys to solve. In this problem, we have 2 points wherein all the forces are converging, that is at point B and point D. So at both point B and point D, we are supposed to write the free body diagram. Free body diagram at point B will have tension because of string BA, tension because of BC, BD, and the weight 200 newtons. Coming to at D, we have 250 newtons, tension due to DE, this should have been DE, and this is TBD. TBD is common to both the points. We are supposed to solve with the point which has got minimum number of unknowns. At point B, we have TBC, BA and BD. This is 3 unknowns. And at D, we have 2 unknowns. It is easy for us to solve D and then come back to point B. Since there are only 3 forces, we can directly apply Lemmy's theorem to point D and find out the value of TBD and DC. After finding TBD and DC, next thing is to find out, consider point B and find out TBA and BC. All other problems are just similar. I'll solve one more problem. Here we have got 2 spheres resting inside a box. Now the diameter of the box is given as 600 millimeter, 400 millimeters, and the weight is 200 newtons. Only thing you need to understand in this problem is how to find out the distances. The total length of this box is given as 720, width of the box is given as 720 millimeters. Now this is, the radius is given as 400 millimeter, diameter is given as 400 millimeter, hence the radius will be 200 millimeter and 200 millimeter. I need to find out the horizontal distance x. Horizontal distance x will be equal to 720 minus 200 and minus 200. Just understand how this minus 200 and minus 200 has appeared. If you consider this total width, it is 720. In this 720, I have to subtract this distance, which is nothing but radius of first sphere. that is 200. Also, I have to subtract this distance, which is nothing but the radius of second sphere, that is 200. Hence, x will be equal to 720 minus 200, which is equal to 320 millimeters. And also, in order to find out the angle at which it is inclined, cos alpha will be equal to 320 divided by 400, which is equal to 0.8, and the angle is 36.86. Now, finding out, writing the FBD of both the spheres, we can easily solve the problem. Thank you.